Hello everybody. In this video, we are going to be looking at mensuration questions. So, let's start off with this first one over here. Now, the question states, a hollow cylinder has an outer radius of 7 centimeters and an inner radius of 5 centimeters. The height is 10 centimeters. Find the volume of metal used. So the first thing we should do is write down what we know. So we know that our outer radius is going to be equal to 7 centimeters. And in terms of the formula we're going to be using, and in terms of the math that we're going to be doing, I'm going to state this as big R. And this is going to be equal to 7 centimeters. Okay? And the inner radius, I'm going to be stating this with small r. So this is equal to 5 centimeters, and small r is going to be equal to 5 centimeters. Okay? Now, the next thing that they give us is the height, right? You can see in the question it says the height is 10 centimeters. So if I'm going to write this down, the height is equal to 10 centimeters, and it's going to be little h equal to 10 centimeters. Now we have our information down. Now this is an essential formula that we should remember in terms of a hollow cylinder. I'll write this down in a different color. Hollow cylinder. This is something to know, right? It's basically going to be equal to pi times the height times the radius squared, which is the outer radius squared, subtract the inner radius squared. Which makes sense, right? This is a formula that you can memorize, or you can kind of derive it, right? Right? Because if we know the original formula of a cylinder, right, we can derive this formula, right? The original formula for a cylinder is the volume, right, is going to be equal to pi r squared times height. Now what's basically happening? The difference between the radiuses are being subtracted right inside. So we're actually getting the volume of the metal used when it's practically hollow. Okay, so remember, this is our formula, and you could of course derive it. So let's now plug in our values to figure out our answer. So therefore our volume, I'm going to write this in green, our volume is going to be equal to pi times a value of 10, which is the height, multiplied, I'm not going to put any units now, times 7 squared minus 5 squared, right? And this is going to be equal to pi times 10 times 49 minus 25, right? 7 squared minus 5 squared. And this is going to be equal to pi times 10 times 24, which is equal to 240 pi centimeters cubed. I'm going to leave it like this, right? You potentially could simplify if you wanted to, right? But this pi is for you to calculate, right? You could plug into a calculator, you can simplify 240 multiplied by pi, but I'm going to leave it like this because it is most simple to understand. Okay, that is it for the first question. So, for our second question, it says this. A cube and a cuboid have equal volumes. If a cube has a side of 6 centimeters and the cuboid has dimensions 3 centimeters times 6 centimeters times height, find the height. So, the first thing to understand is that a cuboid is basically a rectangular prism, right? And a cube, we know what a cube is, right? So, something to note is that the volume of a cube is equal to length times width times height, right? Now, we can highlight that. That's something important to understand. Therefore, we can find that the volume of a cube, of our cube in this case, since it has a side of 6 centimeters, it would just be 6 cubed. So the volume of my cube would actually just be equal to 6 cubed. Since the length is 6, the width is 6, and the height is 6. That's how it was going to work for a cube. So what is 6 cubed? 216 centimeters cubed. So that's the volume of our cube. Now we need to find the height of the cuboid. And they have equal volumes. So remember, the volume of a cuboid is the same exact thing. It's basically equal to length times width times height. Now, there's a little different thing than a cube, because a cuboid can actually have a different length, a different width, and a different height, as we can see here. So now all we have to do is plug in our numbers and isolate for our height. So we know this is going to be 216 centimeters cubed, as both have the same volumes, and this is going to be equal to the length, 3 centimeters, and then the height, which is, the width, which is 6 centimeters, and the height, which we don't know. So we can multiply 3 and 6 together, we'll look at 18. So 216 centimeters cubed is equal to 18 centimeters times height. Okay, now we're actually going to divide here. So 216 centimeters divided by cube divided by 18. Usually don't want to inclusivize units. This would be centimeters squared if we were considering this to be a variable. But we're not going to really work with that as of now. I wouldn't want to work with units. Just forget about that, okay? We're not going to worry about this cubed or anything. I'm actually going to remove it. Try not to work too much around with those. I'm going to remove all the units here. Just do the math and add the units at the end. But don't forget your units though, right? It just depends on your teacher. It depends on you, right? Okay, so then we divide it by 18. It's going to give us a height. 216 divided by 18 is 12. So therefore the height in this case of my cuboid is 12 centimeters. Okay, so our third question states this. A rectangular field is 25 meters long and has an area of 300 meters squared. A 1.5 meter wide path is to be built around the field. Find the area of the path. So we know that our length is equal to 25 meters, right? We know that our area equals 300 meters squared, but we don't know our width. So the first thing would be to find our width. And to that, let's make a diagram to kind of understand this a little better. So our length is 25 meters. We don't know our width, also known as the breadth, and we're trying to find it. But we do know this area is 300 meters squared though, right? So we can have our formula here. Remember that our length times the width equals the area, right? So then therefore, the width must be equal to the area divided by the length. So let's put this formula into work. What is the area in this case? 300 meters squared, right? And it's being divided by our length in this case, which is 25 meters. So the meters are canceling, and we're going to be left with just, put this in a better manner, this is what we cancel, and we're going to be left with 300 divided by 25 as our width, which is 12 meters. Okay, so therefore the width is equal to 12 meters. We figured this out. Equal to 12 meters. That was step 1 of our problem. So now we can replace this as 12 meters. Okay, let's do that. Now what we need to do is we need to figure out the area of a path that's going to be made. So we're going to be having a path that's going to be going around our rectangle like this, right? And it's going to be like that. And the width of the path is 1.5 meters. So this right here is going to be 1.5 meters here, and 1.5 meters here, 1.5 meters here, 1.5 meters here. Now the trick to this question is to actually find the total area of this entire shape, and then subtract 300 from it. So then we're going to be left with this area, this path area that we're going to be left with, right? So let's get to actually doing it. So to do this, the first thing we have to do is actually extend our length and width, right? Our 12 meter is going to be extended by 1.5 times 2, 3 meters. So therefore our new width is going to be equal to 12 meters plus 3 meters, which is equal to 15 meters. And our length, put it right here, our length is going to be equal the same idea out here, which is going to be equal to 25 meters plus 3 meters, which is equal to 28 meters. Because you can see here, if we have a big rectangle, this length would be 25 plus 1.5, because this is 25, right? Don't get confused. This line is 25. This line is 12, right? This line is going to be 15 meters. This line is going to be 28 meters. Okay? Now we're going to find the area. So it's going to be the total area. I'll put that in pink. Total area. And that's equal to 12 meters multiplied, 15 meters multiplied by 28 meters, because these two, right, are new. Find the total area. So 15 times 28 is 420 meters. Okay? Squared. All right? That's the total area. Now, our old area, so to find the area of path is going to be this. This is going to be 420 meters squared subtract 300 meters squared. And that's going to give us an answer of 120 meters squared. Okay? So this is going to be the area of the path. That's it for question number 3. So this question is a little bit more simple. So the question states a cylindrical water tank has a radius of 3 meters. So radius equals 3 meters. And a height of 5 meters. How much water can it hold? So water can it hold? This is the key point here. Water can it hold? This points to volume. So remember, volume is equal to pi r squared times height, right? So a good way to memorize this is pi r squared is the area of a circle, right? So it's one circle. But imagine circles stacked up on each other in accordance to the height, right? That's the way I like to think of it. And so you're going to be, this will be the height, right? Say this is 3 meters high, worth of these circles, right? So it's going to be built up on top of each other. And that's how you're getting the volume. I know that may not be a really great example to explain it, but that's how I like to think of it. But this formula is important, okay? So volume equals pi r squared times h. So pi times the radius, in this case, 3 meters squared, times the height, 5 meters. And once you plug this into your calculator, you should get your answer. So pi times 3 squared multiplied by 5, which will give us 45 pi, which is 100. So I'm going to 45 pi, which is equal to 141 meters cubed. That's it to solving this question. States a solid is made by attaching a hemisphere on top of a cylinder. The radius of both the cylinder and hemisphere is 7 centimeters, and the height of the cylindrical part is 30 centimeters. So A asks us to find the total surface area of the solid, and B asks us to find the volume of the solid. So let's start with A. The first thing I would like to do is actually visualize my shape. So I have a hemisphere, right? A hemisphere, and the base of this hemisphere is actually going to be a cylinder. So it's like a complex shape that's going on here, right? And it says the radius of both the hemisphere and the cylinder are both 7 centimeters, right? And this height of the cylindrical part, which is from here to here, is going to be 30 centimeters. So there are actually 2 things that you need to know for this first part. So the first thing is the curved surface area of a cylinder, right? And there's actually 3 things actually thinking about it even deeper. The first 2 things are curved surface area of the cylinder and the curved surface area of the hemisphere. You also need to know the base of the cylinder, which is the bottom, since the top is actually covered by the hemisphere. So we need to worry about that. It's like wrapping this shape, right? We're wrapping this shape up with wrapping paper, right? So therefore we have to worry about this bottom part as well. So it's fairly simple. It's just a circle. So what will be pi r squared? So what is this bottom? We'll do bottom. The bottom is what? Pi r squared, right? What is the surface area of a hemisphere? So we're going to look at, so curved surface area of a hemisphere is something we should know. Let me put it right here. The curved surface area of a hemisphere is actually 2 pi r squared, right? This is something we should know. We should know this, right? It's really important. And the curved surface area of our cylinder is equal to 2 pi r h. Right? So this is the curved surface cylinder, the surface area of a hemisphere, and we got the part of the bottom. All we have to do now, add these three together. So our total surface area, right here, total surface area is just going to be equal to 2 pi r h plus 2 pi r squared, right, plus pi r squared. So remember all these three surface areas. So if we were to simplify this, we can simplify this as 2 pi r h plus 3 pi r squared. Now once we plug everything in, I'm going to plug everything here. So we're going to get 2 times 3.14 times 7 times 30 plus 3 times 3.14, right, times 7 squared, okay? And our answer to this, if we once you plug it into the calculator, should be 1,780.38 centimeters squared. We have units inclusive of. So this is going to be, so then we're therefore total surface area is this 1780.38 centimeters squared. Now let's do part B, which is to find the volume of the solid. So what do we have to find? Volume of solid. Now this should be easy to understand, right? Because we need to know two things here. The volume of a cylinder and the volume of a hemisphere, right? The volume of a cylinder, right? I'm going to put here cylinder. Cylinder is pi r squared h. Whilst for a hemisphere, it is 2 over 3 pi r cubed. So therefore our volume total is going to be equal to pi r squared h plus 2 over 3 pi r cubed. So now let's plug in our values and get our final answer. It's just going to be, I'm going to take pi is 3.14, so 3.14 multiplied by 7 squared multiplied by 30, which is the height, plus 2 over 3, taking as 3.14 for pi, multiplied by the radius of 7, which is going to be cubed. And our final answer, when we calculate this, is 5333.15 centimeters cubed. All right, so therefore, the total volume of the solid is 5,333.15 centimeters cubed. That's it to solving this question. So for our final question, it states this. The volume of two cubes are in the ratio 27:125. What is the ratio of their surface area? So firstly, we have to write down the ratio that we just found out. And that is, basically, I'm going to put equals to 27 is to 125. That's our ratio. So what we can do is relate the volumes to edge length, right? Let the edge lengths of cubes be A1 and A2, right? So our edge lengths are going to be A1 and A2 relative to our cubes. Now, since volume, right, is equal to A cubed, therefore this has to be true. A1, right, divided by A2 cubed has to be equal to 27 over 125. So it's like, that's what's happening here, okay? So we're basically finding the edge length ratio in this case. So this is going to be, if we write here, it's just going to be A1 over A2, which is then equal to the cube root. If we take the cube root in this case, we're going to get 27 over 125. And the cube root of this is basically going to equal 3 over 5. Okay. Okay, so now we basically found our edge length ratio. So this is going to be our edge length ratio. Edge length ratio, that is 3 over 5. Okay, now since we've got the edge length ratio, what we can find is the surface area of a cube, right? So the surface area, remember, of a cube is just 6a squared or 6n squared, right? So the surface area ratio is just going to be a1 over a2 squared, which is then going to be equal to 3 over 5 squared. So this is going to be equal to 9 over 25. Okay, so therefore, the surface area ratio, right, is going to be 9 over 25. This question is a little bit tricky because we're working with ratios in this case, right? First, we find the edge length ratio, and then we're going to be finding our surface area ratio, right? I hope this video helped. Have a good day.